All right, so today we are going to look at doing some tests for symmetry within our functions. So this first area is kind of in your review question. If we think about what an even function is a function with symmetry to the y-axis. So again, this is in your definition. You don't need to write it down, but you can have a little space to write a little bit of something. So the y-axis would be that vertical axis. So two functions that you know of that are even functions are a parabola. And the other one that you are aware of that we've talked about before is an absolute value graph. So if we think about drawing down this y-axis or this vertical line, and I were to fold those graphs in half, if I fold them on top of each other, they will mirror each other, right? Kind of like when you were younger, and you had those art projects where you would put a bunch of paint on the page and then you'd fold it and then open it up and it looks like a pretty butterfly, all with perfect symmetry. So that would be even symmetry. An odd function has symmetry with the origin. So our origin being the point 0, 0. So two functions that you know of that have odd symmetry are a linear function and our cubic function, kind of that disco man graph. Those are two that have symmetry with the origin. So if I think about this point right here and this point right here, if I were to fold my paper in half and then in half again, I would get my symmetry around the origin. So we're going to think about how do we test to see if a function is even. Well, if I think about that even function, I'm going to use the parabola. Testing for an even function says that when I put in, first I'm going to get a point. So I have my point x, and then this right here would be f of x, input, output. Testing for an even function says when I put in negative x, do I get back my same y value from the original point? So if I go to negative x, this up here is now f of negative x, because my input, output. Are these two things the same value? And in this case, yes, they are. So we said that this has y-axis symmetry. To test for an odd function, I'm going to start again with one that we know. So I'm going to start with the cubic function. This one says that if I take some value x and get my point back out here, if I take that same x value but in the other direction, oops, erase that real quick, sorry, a little bit of a writing error. This should say f of negative x, okay? So what this test is asking us is when I put in negative x, is that output equal to the exact opposite of when I put in x? Well, here we've got this y value. I went over and up. Did I go exactly backwards and down that same amount? Just in the opposite direction? And the answer is yes. So that's how we test for an odd function. There's symmetry around the origin. So to officially test, we want to find f of negative x. So we're going to plug in negative x. If we get back our original function, great, it's even. If we get back exactly the opposite of our function, great, it's odd. And if we get back some parts that are positive and some parts that are negative, we call that some sort of combination, then it's neither even nor odd and it does not have symmetry. So to test, I said we're going to start by plugging in negative x. So I'm going to find g of negative x, which means I'm going to take negative x and cube it minus 1. Well, that means that g of negative x is equal to negative x to the third minus 1. Well, if I compare this to my original function, my original g of x, my x to the third is now negative. So those ones came back opposite, but my negative 1 came back as negative 1. So this one came back opposite, this one came back the same. So if I look back up at this part, which you might want to write down in your notes, sorry, I'll give you a minute to do that. Still writing, trying to give you time. So I came back with some other combination, because one part of mine came back opposite and one part came back the same. So this was some other combination, in which case this function is neither. Good spelling, Ms. Schwartz. Okay. For this next one, I'm going to start with my same approach. I'm going to find what happens when I plug in negative x. Okay, so I'm going to go through it. I'm going to simplify a little bit. So f of negative x is going to be equal to negative x to the 4th power is going to make it positive, and then I'm going to take the 3rd root of it. So I'm taking the 3rd root of negative x to the 4th is what's happening there, which would be 6 times the cubed root of x to the 4th, which is really 6x to the 4/3 minus 5. So if I compare, this term is exactly the same as, exactly the same as that term. This one, minus 5, is exactly the same as that term. So when I plugged in negative x, I got back that everything was exactly the way that I started with it. So this is an even function. Now, I know it's been a while since you've seen things like 6x to the 4/3. We're going to continue practicing with those in the course. The big thing that I want you to get out of this part of the video is that to do our test, you want to plug in negative x, and then you want to ask yourself these questions. Did it come back the same? Then it's even. Did it come back opposite? Then it's odd. Did it come back some other combination? Some terms were the same and some terms were opposite. Then your function is neither even nor odd. All right, we're going to do a real quick review. This is from just algebra knowledge, just to make sure you're good with substituting in values. So if I want f of negative 3, that means that everywhere I see an x, I want to replace it with a negative 3. So this is going to be 9. Negative 3 times negative 3 is 9. This is going to be 1. So when I plugged in negative 3, I got an answer of 19. So that gives us our coordinate point with an input and an output. F of x minus 5 means everywhere I see an x, I want to replace it with x minus 5. So I'm going to square this, x squared minus 10x plus 25. And I'm going to distribute this guy. Do some mental math. I've got my like terms. X squared, negative 10x and negative 3x makes negative 13x. 25 plus 15 gives me 40 plus 1. So f of x minus 5 is equal to this quadratic. This last one deals with some of the stuff that you will have in your practice problems. G of negative 3, using this graph, says that when x is negative 3, what is my y value that I get back out on my function? My y value I get is negative 1. Then it says when x is 1, what is my y value that I get back out? That gives me an answer of 6. All right, that's it. Hopefully you remember your big test for symmetry. Plug in negative x. Did it come back the same? It's even. Did it come back opposite? It's odd. Weird combination? It's neither. Spelled correctly with the I where it's supposed to be. All right, that's all.